All right, hi, I'm Adam, and I'm here to talk about how I created this library, Django Capture on Commit Callbacks, which is a bit of a mouthful, but I believe the long name is justified. So that's about this package. This is what it looks like on PyPy. And that's a yak shave from my book. I went off and wrote this package to scratch an itch of how to speed up tests. It's like a missing tool in the community, as it was. I wrote it up in this post as well, so that you can refer to like what it does afterwards through this blog post. So what does it do? Here's the view code I was just talking about that you couldn't see. So yeah, there's a functional view. It handles a form, and when the form is valid, it's going to go send an email, but it does it on commit. So this is a decorator provided by Django's database system, so that you can pass it a function, and that function will only be executed later when the transaction commits. So this is a callback. And this will go and send an email, and we do it on commit because if the form was saving any data above this line, then the email that got sent could refer to that data. So if you're testing without my package, then you're going to need to use Django's built-in transaction test case. This is the slower version of the default test case that you'll want to use normally, but it allows the tested code to commit transactions. So this view will be wrapped in a transaction. We use the test client to go and hit the view with some data. And that goes through the form, and then the transaction on commit hook, and then as the view exits, the transaction commits, and then the test, and then the email can be sent, and then we can make assertions that the response looked good, but also the email was sent. Actually, disregard this assertion in the middle. That's from the next slide that I forgot to delete. So when you use my package, you get this helper where you can capture those callback functions that are being hooked into transaction on commit, and then tell them to run at the end of this context manager rather than waiting for a transaction to commit. And then you can use Django's normal test case for your tests. And this creates a transaction but rolls it back. So the transaction around the test will never commit, but we can pretend that it commits and execute those callbacks. And then again, we can see that the mail has been sent, and we can also check that there was only one callback sent because the context manager provides them to us in a list. And the main motivation to do this is test speed. The transaction test case is very, very slow in comparison to test case because it doesn't know what data you've added to your database during the test. So what it has to do is like flush every table for every model and then carry on to the next test. And this slowness actually like increases the bigger your project gets, because the more models, the longer you go on, the more models you have, the more data it has to flush. So why do we want this? Why would I build this in a package? Well, I was solving this ticket inside Django, which had been opened 18 months ago, and it was a fairly long-standing feature to actually add some kind of helper for this exact problem. 18 months, I'm pretty sure I was building some version of this helper long before 18 months ago as well. So I've seen this in many different projects, and it was definitely time for it to come into Django core. Several of the comments on this ticket were also people's homegrown helpers, but they will have various problems for general purpose use. So here's the pull request, which I started on 20th of May this year. And as part of baking the pull request, I also made it into a package so that I could develop the idea and also use it in projects before the Django version this will be released in, and based upon when this got merged, it's only going to be released in Django 3.2, which is next year. It's still about 8 months away. So the package is really the way to get the future Django feature today. I've got 2 times the same screenshot here. Okay. So what is inside this package? You get a test case mixin class that you add into your test case classes to give you this capture on commit callbacks helper. And it actually is only 23 lines of code with 86 lines of tests. During development and making this package, I actually managed to iterate a few times to change the amount of code there and whittle it down over time, actually. And I made it support Python 3.5 through 3.9 and Django 2.2 to 3.1. Although, because it's so little code, I suspect it works outside this range too. What do I use to build this package? So I kind of have a standard recipe I'm using on all my packages, and I'm going to walk through a bit of that now. The tool I use to actually build the package and deploy it is the kind of plain old setup tools. So if you've looked into Python packaging, you'll know there's kind of the setup.py file, and that's for setup tools. And more recently, setup.cfg can contain some of the same data, but because it's not an executable Python file, it's just an ini file, I think it makes more sense to use that. It avoids adding any kind of bad patterns. And there are other tools like Flit that help you build a package, but I prefer to stick to the vanilla tooling so that I know that everything is probably going to work and it's definitely going to be possible. So this is just the top of my setup.cfg file. You can see you basically just name some things like the PyPI name, what the current version is, where to read out the description, and various other things in that file. For testing, I like to use PiTest. On top of this, for this project, because it's Django, we need the PiTest Django plugin to set up Django during tests. And I'm using PiTest cov, which is the PiTest wrapper for coverage.py, and to check that we have 100% coverage of the code, which isn't so hard with 23 lines, but it's worth checking all the edge cases. So here's what's in my PiTest.ini for this project, telling it what to cover, how to report on the coverage. This DS thing is like where the Django settings are. And for testing across multiple versions, I use Tox. So this can run a grid of tests, and it will make a virtual environment for each, and then install the requirements and run the test commands in each. So that's how we test from Python 3.5 through to 3.9, and then across each Django version that's supported for those Python versions. And this command that it's running is actually just PyTest, but I'm using a few flags to check that no warnings are raised during the test run. For checking the code quality, I'm using a tool called Precommit, which I really love. This can run linting checks before you commit with Git, and it also can be used on your CI system to rerun those same hooks and check that everything is as it should be. So here I'm running a few tools. I'm using Black, which reformats the code. Black is a code auto formatter, and it's something we will add to Django core once it's no longer in beta. But it's probably worth adopting on your own projects today. Check manifest. This is just for Python packaging tools, and it checks that this particular file called manifest.in is correctly set up so that all the files in the package are shipped. flake8 to check for common Python errors, and isort to sort all the imports alphabetically and group them. So that's the main things I'm running through pre-commit. And then I also have a GitHub Actions workflow. So GitHub Actions runs the various things we've seen there, talks and pre-commit for new pull requests. So the main strategy here is to run one job per Python version and then run everything that was defined inside talks for that Python version inside that test run. So this will fan out across the talks grid and run all the different Django versions supported by each Python version. And then on Python 3.9, it also runs pre-commit. So once you've put all the tools in place, you can put some lovely badges on the README to show off all the things in usefield package. So that's what I've got here. And I think that's pretty much it for this talk. I hope this has been a useful tour for seeing the kinds of things that go into building a package on PyPy, and how that can be useful for other projects too.